Okay, so here in this video we're going to tackle the remaining indefinite integrals. The indefinite integral of e to the u du. Remember, we're looking for a function whose derivative is e to the u. We'll recall that the derivative of e to the x is e to the x. So a function whose derivative is e to the x is e to the x. Therefore, the indefinite integral of e to the u du is e to the u plus c. So some examples on this one. The indefinite integral of e to the 4x dx, we would choose the u to be 4x, choose the u to be the exponent. And we hope that when we take the derivative of both sides with respect to x, we get du equals 4 dx. Put a 4 in, take out a 1/4, and this now would become 1/4 the indefinite integral of. This would become your du. This would become e to the u. And now the indefinite integral of e to the u is e to the u, so it would be 1/4 e to the u plus c. But u is 4x, so it would be 1/4 e to the 4x plus c. And obviously if we took this derivative, we'd get this function back right here. Okay, another example is the indefinite integral of e to the x squared plus 1 times x dx. So obviously try choosing u to be the exponent. U would be equal to x squared plus 1. Du would be equal to 2x dx. So I've got an x dx here. So if I put in a 2 and take out a 1/2, I would now have this become 1/2 times the indefinite integral of e. This becomes the u. And the 2x dx becomes the du. And that answer is, of course, 1/2 e to the u plus c. But u is x squared plus 1, so that would be 1/2 e to the x squared plus 1 plus c. Okay, another example. The indefinite integral of e to the tangent of root x power times secant squared of root x all over root x dx. So something like this could look intimidating or complicated, but actually the more stuff you have going on here in the integrand, the easier it is. If you think about just choosing u again to be the exponent, tangent of root x, du is, the derivative of tangent is secant squared root x times the derivative of the inside, which is 1/2 root x dx. So you've got all of this in the integrand, provided that you put in a 1/2 and take out its reciprocal, which is 2. So then all of this would become the du, indefinite integral. Put the 2 in front, and this would become your u. So this would be e to the u. So that antiderivative would be then 2e to the u plus c, which would be 2e to the tangent of root x plus c then. Okay, and just one more is, suppose you get the indefinite integral of x plus e to the 5x minus sine of 2x. And all of this is in parentheses. Don't forget that you can distribute the indefinite integral over pluses and minuses. When you see an integrand that we know the form of, you can think of distributing this over each of these and doing each of them separately, like this. And the indefinite integral of x dx would be x squared over 2. This antiderivative would be, as a shortcut, the function itself, and the derivative of the exponent is 5, but the antiderivative needs its reciprocal, 1/5. so that when you would take the derivative, 5 and 1/5, these would drop out to leave you with 1. Minus the antiderivative of sine is negative cosine. This would become then positive cosine. Repeat the argument. And the derivative of 2x is 2, but the antiderivative needs its reciprocal, which is 1/2 plus c. That's the shortcut. Or you could do them each individually. Choose this to be your u. du would be equal to 5 dx. Put a 5 in, take out a 1/5. And then likewise over here, you could choose that to be the u. du is 2. Put in the 2, take out the 1/2. So you have to recognize that when you have a quantity, that you can split up the indefinite integral at the pluses and the minuses and take them each individually. Okay. Another one again to look for is something like this. Just the indefinite integral of e to the pi x minus sine of 3x dx. Obviously we don't know of a form that would match this as a whole quantity, but individually, yes, we could split this up like that. And the indefinite integral of e to the pi x is the function itself. The derivative of pi x is pi, so the antiderivative needs its reciprocal, which is 1 over pi. And then the antiderivative of sine 3x, when the answer is a c function, it's negative, so it would be plus cosine of 3x. The derivative of 3x is 3. Its reciprocal is 1/3 plus c. Again, that's the shortcut. Or you could choose each of these to be the u, and du would be equal to pi dx. Put a pi in, take out a 1 over pi. Over here, u is 3x, du is 3 dx. Put a 3 in, take out a 1/3. And that's just the longer way of going about it. Okay, so that's the first video, and that is on e to the u du.